right, so 7.3a, this is right triangle trigonometry. Today we're going to focus on the portion of it that's called trig ratios. And I'll be explaining what these trigonometric ratios are throughout today and how we can identify them and then use them to help us solve for some things. All right, this is just a real quick review of right triangles. In a right triangle, you have two legs and a hypotenuse. We know the legs are the ones that come off the right angle. And we've got the Pythagorean theorem, which we've been using for the last few days, or we used last week for solving for missing side lengths. A squared plus b squared equals c squared. Right? And when you wonder what is trigonometry, it's the relationship between the side lengths and the angle measures of a triangle, specifically a right triangle. Okay. Just like we know that when we have the special right triangles, right, where we have angles of 30, 60, or 90, and 45, 45, 90, there's a specific ratio that we know exists between the side lengths. Now, the reason why those are called special right triangles is because they end up being manageable ratios, okay, where we've got things like A over 2A. Okay, we know the shortest side in the 30, 60, 90 triangle is half the length of the hypotenuse. We know those ratios are consistent, and they're consistent because of the angle measures that are being used. And that's what trigonometry is. It's identifying that consistent ratio based on an angle measure. The problem is that these ratios end up being pretty ugly looking. They're not whole numbers all the time. So because of that, they're not as easy to use. And back before calculators, there used to be like these long pages and pages of these ratios based on angle measures. But now with the calculator and with phones and things like that, you can just plug them in and actually get these lengths you can get lengths and you can get ratios very quickly. So we're going to be focusing on this relationship today. We're going to be identifying what those ratios are. More today, just identifying where you get the ratios from, and then Thursday and Friday, applying these ratios to find some missing side lengths and angle measures. Okay, so there are some labels we need to be aware of with regards to our right triangles using trig functions. Okay, so within a right triangle, there's the right angle, and then there's these two other angles. Now, if we focus in on one of those angles, right? So we're going to focus in on this top angle here. This is a Greek symbol theta. Yeah, that's the Greek symbol theta. A lot of times we use the Greek symbol theta to represent as our variable for an angle measure. Now, we may not know what the angle measure is, but we can say that the angle is theta, kind of like when we use x a lot within our variables. Or we use r for our radius. We don't know what those measures are all the time, but we can use them to represent those lengths. In this case, theta is representing the angle measure. So if we focus on this angle here, the theta angle, there are three sides that we can identify, right? The one that's obvious that we've used before is the hypotenuse. The side directly across from it, we call that the opposite side. And the side that goes alongside it is the adjacent. The way that I usually identify these is the same way that I label my 30, 60, 90 triangles. I usually do the shortest side or the side across from the angle. So I go opposite, hypotenuse, and then adjacent last. But you can label them any way you'd like. it's important that we're able to identify the opposite, hypotenuse, and adjacent based on the angle that we're using. Okay? Because there's three angles here. When you're using trig, you don't usually use the right angle as part of your trig. You're using one of the other two angles, and you need to identify which one you're using because that's going to determine what's opposite, adjacent, and hypotenuse. Hypotenuse will always be the hypotenuse, but the other two could flip depending on the angle. So the trig functions we're going to be using are called sine, cosine, and tangent. All right. Now written out fully, it's sine, cosine, and tangent. But a lot of times we refer to them in the shortened three-letter version: sine, cosine, tangent. It's not sin. We call it sine. It's sine, cosine, and tangent. And on any calculator, you can find these trig functions. Now, the reason why we have three of them is because if we're talking about a specific angle measure, there's three different pairs of ratios that we can set up. And each one of these, sine, cosine, tangent, represents one of those ratios. So sine, okay, sine, it's equal to the ratio of the opposite side length over the hypotenuse. Okay? So we would say sine of theta equals O over H, opposite length over the hypotenuse length. For instance, if we had the 30, 60, 90 triangle that we've been working with, the opposite side would be A and the hypotenuse is 2A, right? If we said A equals 1, that means the hypotenuse would be 2. So if we were to write down the sine of 30, that would be 1 over 2, or 1/2. Okay. In my calculator, I could type in sine of 30, which is, the trig functions are right in the middle of calculators usually. Sine of 30, I get 0.5. It gives me that ratio. Right? And it knows that no matter what the lengths are, it'll always have a ratio of 0.5 or 1/2. Because even if this length were to be 25, hypotenuse is going to be double that, be 50, still going to be 1/2. So sine of theta is always equal to the ratio of the opposite side over the hypotenuse. Okay. So if we had these are just pretty quick examples here, but we had these three, we just identify theta, and we got our opposite over our hypotenuse, right, which would be 6 over 10, which reduces to 3/5. In the middle triangle, sine of theta is going to be 2 over 7. And the right one, sine of theta is going to be 4 over 9, opposite over hypotenuse. 4 over 9. Cosine. Cosine is the adjacent over the hypotenuse. And so the same idea as cosine, as sine. So our ratio now involves our adjacent length over our hypotenuse length. both sine and cosine, the hypotenuse will be the denominator. So, right?
Yeah.
So cosine is the adjacent side length over the hypotenuse. Where sine and cosine, again, hypotenuse is always the denominator. Some examples. All right. The left triangle, we got the adjacent length would be 2 over 12. For the middle example, our adjacent is 5 over 11. And for our right example, the adjacent will be 5 over 6. Last one is tangent. Okay. Tangent is, it does not use the hypotenuse, it uses the two legs. Tangent is the opposite over the adjacent, the opposite length over the adjacent length. So again, we identified the angle we're working with. So theta is here. Opposite over adjacent, we get 4/3 for the one on the left. The middle one, we get 2 over 4, which is 1/2. The one on the right, 5 over 7. Opposite over adjacent. Now, this is, it's a mnemonic, yes, mnemonic. So, SOHCAHTOA, okay, is a good way to remember the order with your trig functions, okay? And another way that you'll see me write it a lot of times is like this. SOHCAHTOA. Actually, we used to show a video that would go over SOHCAHTOA. They used to call him the Greek Indian chief, SOHCAHTOA. But it's a way of remembering that sine equals opposite over hypotenuse, cosine equals adjacent over hypotenuse, and tangent equals opposite over adjacent. SOHCAHTOA. All right, so this is just a real quick example here of a triangle that's a 3, 4, 5 right triangle. If we make this our angle up here, we'll call that theta, right? And we want to identify the sine, cosine, and tangent of theta. Well, the sine of theta, if we identify this is our angle, then this will be our opposite. The one straight across will be opposite, that's side length of 4. The hypotenuse is across the 90, that's 5. And the adjacent is that third side. In this case, it's 3. So sine will be opposite over hypotenuse, which is 4 over 5. Cosine of theta would be adjacent over hypotenuse, so 3 over 5. And our tangent of theta would be our opposite over our adjacent, or 4 fifths. All right, so today, okay, and this is what we're going to be kind of going towards. We're not going to do this today, but what we're going to be using these trig ratios for is if we're given side lengths or if we're given an angle measure, we are able to solve for missing side lengths or missing angle measures. Right? And we can do that setting up an equation. Right? We can set up an equation with our trig functions. Right? Again, we're going to be focusing on that a little bit more on Thursday and Friday. And we're going to be finding side lengths on Thursday using trig functions. And then we'll be finding angle measures on Friday using trig functions. And we'll have some notes on that as well. But today I want to focus on identifying and getting more familiar with just the ratios and setting up those, just making those equations. So we do have a little assignment for you guys that